guys, thanks for being here and watching this. I am going to walk you through a couple of, actually to be exact, three integration techniques to make your life easier. The first one we're going to start with is called integration by parts. And as the name suggests, it's exactly that. It's taking an integral apart and then, work through it that way. Now, what is integration by parts? Some really smart mathematician back in the day have come up with a technique to solve integration like this that you can't solve with something easier like u substitution, because you do have an indestructible function right here, meaning that it just repeats itself and it goes into a circular argument that would just a crazy maker. And they've come up with this formula. Now, this might look crazier than the integration itself, but let me walk you through it. It will be really easy. So what this says is, break this apart into pieces that will fit into that formula and then put it back together and solve through it. So let me show you what that exactly means. It says to look at your integration as if it was u at u dv, and then define those parts and then plug into that formula and solve. So the reason I've picked this integral for you guys, no clever reason behind it, honestly. It's just a shorter one, and it demonstrates the points pretty quick and easy. So I am going to choose my u to be x, and I'm going to choose my dv to be e to 2x. Now, how about the rest of it? We still need du and we still need v. So what to do? Well, look over here. It's very easy to come up with it, isn't it? Du, derivative u, is only du because it's 1. When you drive that, it's only 1. And du suggests that we do have 1 as our coefficient. And same goes for x. It's dx, which suggests that there is a 1 here. For v, however, this might be a bit harder, but as you know, it is completely legal for us to make our own life easier by doing the same operation on both sides of an equality. As long as we're doing the same thing, we're totally within our legal limits. Well, at least in math. So d and the integral sign cancel each other. Now we're left with this. So I've gone ahead and pre-solved that for you to save some time and spare you from my crazy handwriting. So integral of e to 2x. Yes, we did say this is an indestructible function, but it's also a very easy one to solve. I'm going to do a u substitution. I'm going to let my u to be 2x, which will give me 2dx, and which is integral of 2x. And then I'm going to divide both sides by 2. 1/2 of du equals to dx. So this is my dx, so I could replace that right here. So what does that tell me? That tells me I'm going to end up with e to the u, which is already defined as e to 2x. But look guys, we have a 1/2 right here. And let me tell you, that guy is really important. I lost 2 points on a test for forgetting that 1/2. I'll never make that mistake again. It sucks. So I'm going to bring that guy right up here. So I already knew that my v equals that. So here I'm going to write that. V equals the thing I just solved there, 1/2 of e to 2x. Now I have everything I need to solve that based on this formula. And at this point, it's really easy cruising. It's just all plugging up. So the formula tells me to time u times v. I've already defined my u to be x. I've defined my dv, v to be 1/2 of e to the x. I'm just going to bring 1/2 right here to save myself rewriting this again. E to 2x. That's u times v, which is x to 1/2 of e to the x. Minus, like this sign says right there, integral of, where were we? Oh, here. V times du. V was 1/2 e to 2x. I'm just going to bring the 1/2 out because it is a constant, and it is a constant of a function. So we don't drive this or we don't integrate this. It's just itself. If it was by itself, then it would have been 0 and we would have been done. But it's not. So our v was 1/2 e to the x, a to 2x times du, and we already defined our du to just be dx. Now let me show you exactly why I picked this kind to solve, because look what I have here. I have integral of e to 2x dx. Isn't that exactly what I just solved here? There you go. So I'm going to rewrite that as, I got 1/2 of x e to 2x minus, I have my 1/2, and I've already defined this to be 1/2 of e to 2x. I do want to go and put down that plus c right here, but look, I could make this look a little prettier. Why don't I do that? Let's simplify this too. 1/2 times 1/2 is 1/4 e to 2x. And now here we are, plus c, voila. That's all there was to it. And if you did pause that video to try the u substitution, I bet you it did not take you this fast to solve it.